Yes, welcome back guys to India's largest e-learning platform, Gradeup, and I welcome you all in this session for ESE paper 1. And guys, the subject going on is material science. And today we are going to discuss about the properties of materials. Okay, and you know there are various types of properties, like some properties are referred as electrical properties, some are said to be mechanical properties. Sajal, I am fine here. So don't compare and don't feel that sir is differentiating us in the name of electrical and mechanical. It is not like that, guys. But it is true that some properties are considered to be mechanical properties and some properties are considered to be electrical properties. And in this session we will be discussing about the mechanical properties. Next session we will be discussing about the electrical properties. So guys, both of them are equally important for you. Yes, Rishav, good morning dear. When we will be having a discussion over electrical properties, then my dear, obviously we will be discussing about electron, mass of electron, energy, all those things, about nucleus. Those things will be coming into picture. Akshay Singh, good morning. Abdul, good morning. But for the timing, now we are going to discuss the mechanical properties. So guys, like whenever I'm going to start the session, this is a small introduction of mine. You can see all these things, you know already, I have discussed many times. So next, my dear, I would like to show you guys a small information that Vision 4th batch is in progress from 15th February. 3 batches are already running full. And yes, good morning Gaurav Vajpayee, Lucky, good morning. And these are the unique feature of the batches, and in case of any query you can definitely contact on this number. And guys, under Gradeup Super, under one subscription you can get the access to various batches, like for ISRO, DRDO, BARC, HPCL, AAI, all the examination, different batches are there, and you can get access to any of the batch under one subscription only. So guys, now we are going to start the properties of materials. So my dear, first of all I will be defining what is a property. Then we will start the properties, and my dear, I will be showing you how the testing of properties are done. So today I am having some animations, some diagrams by which I will be showing you how the properties testing is done. Kiran Dage, good morning dear. So my dear, first of all let us see what is a property. So my dear, whenever I ask a student that what is a property, generally students are defining any measurable characteristic to be a property. But my dear, this is not the correct definition of property. If you want to define what is a property, then my dear, the best definition I would like to say, these are the quantitative indices. These are the quantitative indices. These are the quantitative indices. Quantitative indices, my dear, it means a number I am talking about. Like let us say 270 MPa, 270 GPa. This is a kind of quantitative index. It is a quantitative number. So my dear, these are the quantitative indices given to the behavior of material. Given to the behavior of material. And my dear, they are given to the behavior of material whenever the material behavior is testing. My dear, it is given to the behavior of material when it is subjected to external stimuli. When it is subjected to external stimuli. When it is subjected to external stimuli. Yes, Kuldeep is asking something. Sir, previous year's question solve honge ka? Yes, dear Kuldeep. Previous year's question of the topics we have covered till now are going to be discussed in the tomorrow's class. तो कल वाली क्लास में हम क्वेश्चंस डिस्कस करने वाले हैं जो भी प्रीवियस ईयर्स में अब तक की मटेरियल साइंस जो हमने पढ़ी उससे आए हैं. और कुलदीप, ना केवल प्रीवियस ईयर्स, I would like to make an announcement here. If you guys want a quick revision of all the topics of paper 1, plus you want to solve some extra question other than previous years, you can join me from today onwards at 10:30 PM on Gradeup app. On Gradeup app, I am coming with a series. In that series, I will be discussing the questions for ESE paper 1 other than the previous years. Previous years I will be discussing in this session only. Tomorrow at 11 AM I will be discussing. Okay, so for sure guys, you just stay with me and with Gradeup, everything will be covered. Okay, so my dear, this is the quantitative indices given to the behavior of material when it is subjected to some external stimuli. Stimuli means loading. So when you are going to apply the external loading condition, then only you can see the behavior and then only you will be knowing the number. So my dear, the perfect example of this, many times you have seen our parents are saying something for us. Our parents are praising sometimes us that he is a very good student, he is just studying all the time. Sometimes they may be saying some negative things about us, that he is becoming angry very soon. So my dear, all these things, how they are saying, they are not having some kind of kundali in front of them, and by reading that kundali, they are saying that isko gussa bahut aata hai, he becomes angry soon. It is not like that, guys. Basically, they have seen your behavior under various conditions, and by looking at your behavior under various conditions, they came to a conclusion that yes, you are becoming angry soon. So my dear, they are getting your property by looking at your behavior when external loading conditions are coming, because without external loading, nobody will be becoming angry. So you will be becoming angry when you will be having some loading condition. When you will be having some difficulties in your life, then only these kind of behavior comes into picture. So my dear, this is something known as property. And my dear, when we are talking about the property, what are the types of property? There are mechanical properties, there are thermodynamic properties, there are some electrical properties. So for different branches, different properties are there. Like we are using some kind of properties in some of the branches, other properties in other of the branches. So based on that, we have defined them with those names. So my dear, today our discussion is related to mechanical properties, and don't feel that I am going to distinguish all of you. No, guys, you all are same for me, because paper 1 is same for everybody. From which branch you are, it is irrespective of that. So today we are discussing mechanical property. Tomorrow I will discuss electrical property, and along with that we will also be having a wonderful discussion over the previous year's questions of engineering services paper 1 from this subject up to the topics we have discussed. So my dear, this is the property, and if you want to have a discussion over mechanical properties today, and as well as I will be showing you the testing of these properties also. So when we are talking about the mechanical properties, my dear, the very first thing that is coming into mind is nothing but strength. This is strength. Strength word is generally also used when somebody asks you what are your strength and weaknesses. What is your strength and weaknesses? So my dear, strength is the maximum value of stress which you can bear before failure or fracture. In other words, it is the maximum value of load which you can bear before failure or fracture. So my dear, it is nothing but maximum value of stress or load a material can bear. A material can bear before failure or fracture. Before failure or fracture. My dear, you might be thinking that why sir have written stress to be load. My dear, as all of you are not related to mechanical and civil branches, you may be from electric and ESE. So you might have listened that stress is force but a area. But my dear, I would like to say, when you will be learning this as per the strength of material, as per the mechanical or civil point of view, then you will be knowing that stress is nothing but force by a point. Force by a point. How? Because my dear, when load is divided by area is having some n number of points. When my dear, load is divided by n number of points, it is nothing but the load given by a single point. That's why I have referred stress to be load only. Okay. Hello Aab. Okay, fine. So Dhruv, good morning sir. When you will take the extra class of basics of project management? Dear, sorry, basically actually that got delayed. I am going to take that class. One class will be from on Saturday or Sunday. One class will be on Tuesday. So I am taking on alternate days so that you guys shall not be getting overloaded. Okay. So I am going to take that on alternate days. One class will be there tomorrow or day after tomorrow on Saturday or Sunday. One class will be there on Tuesday. So on alternate days I will be taking. Why I have not taken from Tuesday to Thursday? Actually the load was more on me, and also for Shivratri yesterday was holiday. That's why. Okay, so what's the difference between UTS and strength? Dear, when you are talking about ultimate tensile strength, ultimate point comes when we are talking about fracture. It is the difference is there between failure and fracture. My dear, failure means, like, let us say sometime what happened is, my dear, let us say you are going to just extend this rod. You are going to apply the force for extension. So when you are going to extend it, you are going to apply the forces. So my dear, there is going to be a loading up to which, if you are going to apply the load, the body will regain its shape and size after removal of load. That property is said to be elasticity. But my dear, after that point, when you are going to load it, yes, Dhruv Gupta, only in your batch we will be completing it. In your batch only we will be completing it. Don't worry about that. Okay. So my dear, now when we will be loading it like this, then my dear, obviously up to some point the body will be regaining its shape and size after removal of load. That is said to be elastic limit. And after that, if you are still loading, my dear, then some permanent deformation will be coming into the body. And once the permanent deformation is entering into the body, it is said to be failure. And my dear, after failure, when this body is going to be divided into two parts, it is said to be fracture. So the stress associated with fracture is said to be ultimate tensile strength. Okay, that is the difference. Basically, ultimate tensile strength is a kind of strength. If you are referring as fracture, it is UTS. If you are referring at failure, it is YTS. YTS means yield tensile strength and UTS means ultimate tensile strength. Hope, Captain Ajay, you are very much clear now. So that will depend upon failure or fracture. Okay, let us move further. So my dear, next property we are going to discuss is nothing but elasticity. This is the elasticity. So my dear, when we are talking about elasticity, it is a property of material by virtue of which the material regains its shape and size after removal of load. So my dear, this is the property by virtue of which material regains its shape and size after removal of load. Its shape and size after removal of load. Its shape and size after removal of load. Okay, so my dear, it is said to be elasticity. My dear, it is said to be when material regains its shape and size after removal of load, it is elasticity. Like you are having a rod, you have applied a force onto that. Because of this force, its length got increased, diameter got decreased, and after removal of load, it is regaining its shape and size again. Like a Costco ball, you just press it. After removing the load, Costco ball will take its original shape. Like rubber, you are extending it and you are removing the load, it will becoming its original shape. But my dear, if you are going to extend the rubber to a larger extent, you will feel its size also got increased. That is plasticity or permanent deformation. So my dear, that is plasticity or permanent deformation. So when I am saying plasticity is the permanent deformation. Plasticity means permanent deformation. Okay, so this is plasticity. My dear, next property I am coming on to is going to be related to ductility. This is ductility. And my dear, there are two properties. One is ductility, other is brittleness. And these two properties are always going together. Ductility and brittleness always going together. So my dear, when we are talking about ductility and brittleness, ductility is defined as the property. As if I ask you what is ductility, I know, my dear, all of you will be defining that. Those who have not attended my classes, those who have attended, they will be correctly defining it. Otherwise, students are defining ductility is the property by virtue of which a rod can be converted into wire. A material can be stretched into wire. So my dear, I would like to say that this is not the correct definition. Like if I ask you what is anger, will you define that, sir, anger is something in which some person can kill another one? No, this is the application of anger. That one person can kill another person, that is the application of anger. So my dear, if you are going to say the definition is not that. My dear, you are capable of converting this rod into wire only after applying the tensile forces. So my dear, the definition of ductility is going to be, it is the ability of a material to withstand the tensile load. Because if this body is not capable of withstanding the tensile load, you and nobody else can convert this rod into wire. Anybody can convert rod into wire if that rod is capable of handling the tension, because otherwise you cannot convert it into wire. So this rod is capable of handling the tension, then only you are converting this rod into wire. So my dear, it is the ability to withstand tension. It is the ability to withstand tension, my dear. It is said to be ductility. And my dear, because of that only you are going to convert it into a wire. And my dear, when we are talking about ductility, brittleness is just opposite to that. Brittleness is something if not ductile. And my dear, this ductile and brittleness, they are the relative properties. They always go hand in hand together. Like ductility and brittleness are something like truth and false. Like in a whole day, if I speak 90% truth, it is very much obvious I will be speaking 10% false. If in the complete day I am speaking 80% false, it is very much true I will be speaking 20% truth. So my dear, always truth and false are going in percentage. Similar to that, ductility and brittleness are also going in percentage. Like if somebody is 80% true, he is 20% false. Good afternoon, Srishti. If somebody is 20% true, he is 80% false. So my dear, likewise, ductility and brittleness are also relative property. They are always together in a material. If some material is more ductile, it is less brittle. If some material is more brittle, it is less ductile. So the point is how we will define it. So my dear, we will define it in a way that if some material is having post-elastic strain to be more than 5%, means after elastic limit, if permanent deformation is more than the 5% of the size, it is said to be, my dear, ductile material. And if post-elastic strain is less than 5%, it is brittle. So my dear, there should be a criteria, because if we say thin, thick, then my dear, thin, thick are relative terms, small, big are relative terms. So whenever these terms are coming, we need to take a criteria after which we will be saying something to be thick, something to be thin. Srishti, project management classes in Boost Up, when it happen, then it will be starting from tomorrow or day after tomorrow. I will be taking one class on Saturday or Sunday, one class on Tuesday, then one class on Thursday. Day means I am going to take the classes on alternate days, and I will be completing the project management in the next week for you guys, for sure. So tomorrow most probably you will be having a class, for sure. Don't worry about that. Okay. So my dear, when we are talking about ductile and brittleness, the materials example, my dear, aluminium is ductile, copper is ductile, iron is ductile, silver is ductile, gold is ductile. Yes. And my dear, for brittle, glass is brittle. My dear, cast iron is brittle. So these are the examples. Yes, quartz is a brittle material. Yes, tungsten is a brittle material. Okay, vanadium is brittle. All these are brittle materials. Thanks, Srishti. Thanks for your words. Even I feel you have not attended my material science. You attend that. Hope you will have the same feeling in this subject also. Yes, dear. So this is about ductility and brittleness. My dear, now I am telling you about some core properties like hardness, and then we will be having some hardness test also. My dear, hardness. So when we are talking about hardness, hardness is defined as resistance to scratches, resistance to indentation. So my dear, hardness, when we are going to define, it is nothing but it is the resistance It is the resistance to scratch or indentation. So resistance to scratches or indentation. Okay. So my dear, what is the meaning of indentation? In the childhood, when you were in the school, you were taking the eraser and compass and you were trying to indent the compass into eraser, my dear. And that thing is said to be indentation, what you were doing with the eraser. And you were easily doing the indentation of the compass into the eraser because eraser was a soft material. If you try the compass on the wall of the classroom, if you try the compass on the wall of the classroom, as the wall was hard, your compass was going to break because, my dear, that was hard surface. So my dear, indentation is easier in soft, difficult in hard surfaces. Indentation Hindi mein bolte dhasna. Yes, if I am going to indent that, yes, that is indentation. And scratch is like this. If you are going to scratch on rubber by your nails, my dear, rubber will get scratch off. But my dear, if you are going to use that scratch over the wall, your nail will scratch off because that is harder. My dear, relatively you can see anything. If you are going to see hardness and softness, they are relative. More hard, less soft, more soft, less hard, for sure, Captain Ajay. So my dear, that is something known as hardness. And when, my dear, we are going to do the studies of hardness, my dear, there are various number of tests which are done for the property hardness. My dear, the testing done are the number of tests. The first test is Brinell hardness test. There is Brinell hardness test to test the hardness. I will be showing you how the hardness is testing. Second is going to be Knoop hardness test. Third is going to be Vickers hardness test. Fourth is going to be, Rockwell hardness test. My dear, fifth is going to be Shore celeroscope. So my dear, these are the various testings. And out of these tests, my dear, my dear, I will be showing you all, but first of all, I am going with Shore celeroscope. What is done in Shore celeroscope? My dear, in Shore celeroscope, basically you are having a surface whose hardness is to be measured. Because I know you have listened about these tests. This is something you have not listened. Till this point. So that's why I am telling you something about Shore celeroscope. So my dear, when we are talking about Shore celeroscope, what we are going to do, my dear, we will be having a cylindrical tube. And on this cylindrical tube, my dear, various readings will be written. There are various readings onto this. Captain Ajay, they are important with respect to names. Like you will be asked that this test is done for which. They will not be saying Knoop hardness test. They will be saying Knoop test. You will be having a question like which of the following tests are used for hardness. And there will be the name of some of the tests. And you need to identify that which are used for hardness testing. This is how the question will be framed for you. So my dear, we are going to have basically now a diamond tool tip. We will be having a diamond tool tip. And this diamond tool tip will be dropped from this position. And when it will be going onto the surface, my dear, it will be bouncing back if the surface is hard. And it will be indenting if the surface is soft. So my dear, if it is going to be bounce back, so my dear, more it will bounce back, more will be the hardness. So more bounce back, means more hard. Less bounce back, less hard. Less hard means more soft. Okay. This is one kind of testing which is done for hardness measurement. My dear, now I am coming on to all other properties in Brinell, in Knoop, in Vickers and in Rockwell. What we do in these tests, my dear? In these tests, we just take a sample of material. We take an indenter and try to indent into the workpiece, and we apply some amount of force. And that amount of force is applied for some second, 30 second, 40 second, 60 second. And after this much second, you are going to check the indentation of the material in which indentation is going to be more, it is going to be softer, and we derive some formulas also for this indentation. And by that formula, we can find out a number which will indicate the hardness. If that number is more, hardness is more. If that number is less, hardness is less. So my dear, I am showing you the very first test known as Brinell hardness test. So guys, are you ready for that? I am showing you that. Are you ready for Brinell hardness test? This is how the Brinell hardness test is done, my dear. My dear, this is a workpiece. This is a workpiece. This is a workpiece. This is an indenter. This is an indenter. So my dear, when this indenter will be coming onto this workpiece, obviously this workpiece will be filling some indentation. And my dear, that indentation, when you will be looking from the top view, will seems to be like this. Obviously, that sphere will be making an indentation like this. And this will be a kind of hemispherical shape. This is a sphere of diameter d, and this is the diameter of this indentation. This is small d. This is the small d. So my dear, small d is the dia of indentation, capital D is the diameter of the indenter. And my dear, when you are going to find out, a formula is defined for Brinell hardness number, and that is P pi d by 2 d minus square root of d square minus d square. And my dear, if this number is more, it means hardness is more. And my dear, if this number is less, the hardness is less. As I said, these are relative properties, but still some numbers are defined to give them some quantitative index number, because quantitative index is required to compare 2 to 3 materials, that which one is going to be more harder, which one is less one. Sir, when will you take the extra classes? Praveen, I already told you that. I feel you joined late. I already announced that I will be taking on one class will be there on tomorrow or day after tomorrow, other will be on Tuesday, and third class will be on Thursday. Means on alternate days I am going to take. Classes will be resumed from tomorrow or day after tomorrow, and they will be alternatively taken. And up to next week it will be completed. Don't worry about that. Okay. So my dear, here P is the load, D is dia of ball, small d is dia of indentation. So my dear, if you want to see another view of this, this is the another view. This is the ball, and my dear, this is small d is the dia of indent. This is how the indentation will looks like, and this H is the height of indentation. This is said to be Brinell hardness test. This is said to be Brinell hardness test. Okay guys, and yes, I am going to write a number how the notation is given for Brinell hardness test. Like if somebody is asking you how to show the notation of Brinell hardness test, I am showing you that. My dear, this is how the Brinell hardness test notation is given. My dear, here 210 is the Brinell hardness number. It is the Brinell hardness number. HB is for hardness Brinell. W is the material for which you are finding out, that is tungsten. My dear, then 5 is nothing but the dia of indentation. Dia of indenter, not indentation, dia of indenter. 250 is the load applied in kgf. 30 is the time for which the load is applied. So you can be given a notation and can be asked that which term indicates what. So this is how, my dear, you are going to show that here this is Brinell hardness number. This means hardness Brinell. And this means the material of which hardness is measured. This is the dia of indenter. This is load in kgf. This is time. Is it clear, guys? Fine, Praveen, got it. And Yes. So we are going to meet tomorrow or day after tomorrow for sure. For sure. Dear, H is not required in the formula. H is not required for the formula. H is the height of indentation. Okay. Okay. Yes. You can see this is the formula. Okay guys. So you have seen I have written the name of many tests, like there were some other tests like Knoop hardness test. You have seen some other hardness test like Vickers test. You have seen some other tests like like Rockwell test. So my dear, all tests have different shapes of indenter. For different shape, different kind of indentation will come, and for different shapes of indentation, different formulas are given. For different formulas, my dear, the different number is defined. Okay, so I am showing you one by one all. My dear, now we are coming on to Knoop hardness test. For Knoop hardness test, you are going to have an indenter which is having a shape such that you will get that kind of indentation. So if you want to see the indenter, I am showing you that indenter, how it looks like. My dear, the indenter will looks like this. Indenter of Knoop hardness test looks like this. This is the indenter. You can see it is a diamond indenter and it is making two angles. This angle is 172 and this angle is 130. So there are two angles. This is 130, this is 172. This is 130, this is 172. Okay guys, so these are the two angles made by this indenter. It is inclined from here, it is inclined from here also. So from two sides it is inclined. So that's why this shape of indentation will be there. Okay. Yes. So if you see this Knoop hardness test, you can see, my dear, these are the load limits which you are applying, 1 to 1000 kgf. Okay, and these are the two angles, 172 degree and 130 degree. And my dear, when you are going to take this type of shape is made, and as I have made this, you can see there are two diagonals. This is one diagonal, this is second diagonal. So here L is the long diagonal. Long diagonal. So this is L, which is the longest one. L is the big diagonal. As two diagonals are there, L is the big diagonal. And my dear, when it is the big diagonal, I would like to show you the Knoop hardness test is like this. This is the formula for Knoop hardness. This is hardness Knoop. The formula is 14.2 F by D square. That D is the long diagonal. You can also write 14.2 F by L square. So this is Knoop hardness number. Okay, Knoop hardness number. When we are saying load to be in kgf, it means whatever it is given, multiply it with 9.81. Multiplied it with 9.81. And my dear, Knoop hardness number, if it is more, hardness is more. If Knoop hardness number is less, hardness is less. So my dear, the major differences are in Brinell hardness test we were using steel indenter, but in Knoop hardness test we are using diamond indenter. That is the major difference what I want to say. Okay, and if you want to see, my dear, how to write the Knoop hardness number representation, so I am showing you that representation, and that representation is like 870 hardness Knoop tungsten 50 by 30. My dear, as you know in the previous case, we were already knowing that indenter will be spherical in shape, so the diameter of sphere may vary. But in Knoop hardness test, the angles are already fixed, 172 by 130. So that's why in this notation, the size of indenter did not come. And my dear, here we have only shows this number. This number is Knoop hardness number. And HK means hardness Knoop. HK means hardness Knoop. If you see, this is the material for which hardness is measured, that is tungsten. My dear, this 50 is nothing but the load in kgf. If you will be multiplying it with 9.81, you will be getting the force in Newton. This is the time for which the load is applied. This is the time for which the load is applied. Time for which the load is applied. Yes guys, this is something Knoop hardness test. Everywhere the concept is same. You are going to indent the indenter into workpiece, and based on that indentation you will be getting the values. Guys, maybe on this topic questions are not much asked in paper, but I want to make you foolproof. If you see the previous year's paper, question have been asked even from the phase diagram. That is the core part of mechanical engineering. But still the questions have been asked in paper 1. So guys, that's why I said you cannot leave anything. That's why I'm preparing you for everything. So don't mind it. It is for your benefit only. It is not for my benefit. It will be very easy for me to discuss only easy topic which everybody can understand by his own. But I am taking the topic which I know you will not be able to understand by your own. For this you want a perfect example, a person who knows everything about that only can tell you about these things. So for us, yes, definitely it is a thing which we discuss again and again. So that's why I thought to teach you that, and hope you are getting in the same manner. My dear, this is something hardness test, Knoop. Next, my dear, when we are talking about, yes, so like we have seen Brinell, we have seen Knoop. My dear, in all others when we are talking about, for Vickers test also we are using the similar diamond pyramid. The difference here is only that in Knoop the angle was 172 degree, here the angle is 136 degree. So my dear, here also the formula is 1.854 load by L square, where L is the longest diagonal. And my dear, as we have already seen this, now I am coming on to the Rockwell. So we have completed this and this. Short cell aeroscope is already completed. When we are talking about Rockwell, my dear, Rockwell test is something where there is no number defined. Why there is no number defined here? Because my dear, in Rockwell hardness test there are 3 scales there which are directly giving you the value of hardness. There is no need to define any hardness number. So Rockwell test is going to be the easier one and going to be the most useful one we are using, because it is giving you the direct values. So my dear, Rockwell hardness test is having 3 kind of scale. Basically the scales are A, B, C, but overall there are 7 scales. A, B, C, D, B, F, G, E. These are the number of scales. We generally study only about 3 scales, E, A, B and C in our colleges. So A, C and D uses diamond cone. My dear, B, F and G using 1/16 inch diameter steel ball. And this uses 1/8 inch diameter steel ball. And my dear, when you are going to use this, you can see these are the loads applied. And my dear, for this, if you see the reading HRA, HRC, HRD, this is how we define. That is hardness Rockwell on A scale, hardness Rockwell on C scale, hardness Rockwell on D scale. Okay, don't see these values. These values you will be getting from the test, and that will be given directly as the hardness number. There is no formula required for that. No dear, numericals will not come from this topic. They will be only asking you about the name of the test. They will be asking you at the maximum about the material of indenter you are using. Like here you are using steel ball. Here you are using diamond pyramid, here diamond pyramid, here diamond pyramid or cone, here steel ball, steel ball. Only that thing is required for you, nothing more than that. Okay, so these are the hardness testings. Okay, even you will not be asked this, but I have given you this. Otherwise, generally student ask me, sir, you have not given about how to denote it. That is also some extra knowledge given to you. Okay guys, this is something about hardness testing. Now I am coming on to the toughness, my dear. Toughness is also a wonderful property we study. What is toughness? My dear, toughness is here, my dear. I am not going into that much detail that is required for technical of mechanical paper. I am going as per paper 1 mechanical. Okay, sorry, paper 1 for all the branches. Okay, so toughness for that purpose in general is defined as, otherwise I show all this property with reference to stress strain diagram. for core mechanical field. But as this is for all the branches, I need not to go, you need not to go into stress strain diagram for this. You can directly understand by the basic definitions. Like toughness says the energy stored, it is the total energy stored by a material before fracture. It is the total energy stored by the material before fracture. And my dear, like let us say you are applying some loads onto a material, and that material will be bearing that load. It will be obviously storing some energy, and after an instant that material will got fracture. So up to that point, whatever the energy stored by the material is said to be the toughness. So toughness is the strain energy or total energy stored by the material before fracture. And my dear, if you want to measure the toughness, what you will be doing, I am showing you what you will be doing for that. For that, my dear, this is the test. There are two tests. One is known to be Charpy test, other is said to be Izod test. My dear, both the tests are performed on the same setup in the same manner. The difference is only how you are putting the workpiece. My dear, only the orientation of workpiece. You are going to put the workpiece as a simply supported beam in one of the tests and as a cantilever beam in the other test. So my dear, as I say, in one test you will be putting your workpiece in this format. In other way, you will be putting your workpiece in this format. This is simply supported, this is cantilever. So just by putting the workpiece in the different manner, the name of the test are different, Charpy and Izod. What you do, you are putting your workpiece here. And my dear, your workpiece is looking like this. You can see, your workpiece is looking like this. This is your workpiece. And the point you can see here, this is said to be the notch. This is said to be the notch. And it is provided because we want intentionally the failure or fracture of the material shall be there from this only. And it should be divided into part along this. So that's why we are providing it here. This is said to be notch. So we are just keeping the workpiece here. And this is a hammer. We are leaving the hammer from this height. You know this height refers to some potential energy. Then this hammer is coming like this and it is going to break this specimen and it will be achieving some height. Obviously, if this height is H0, this height is H1. So H1 will be lesser than H0 because the energy it was having will getting converted into kinetic energy here. But out of some energy have been spent in breaking the workpiece, and then it will not be achieving the same height. So H0 is the initial height, H1 is the final height. So my dear, H0 minus H1 is the loss of height, and that will indicate the loss of energy. Okay, yes, very good, Sajal. So that will be indicating the loss of energy, because my dear, that loss of energy is the energy stored by the specimen, and that is the toughness of the specimen. So guys, this is something known as the testing for toughness. Hope you are getting it in a wonderful manner, guys. Please tell me that whether you got it or not, and then I am telling you a last test and then we will leave it. So if you want to know, my dear, the specimen in the Charpy test, yes, in the Charpy test it is kept like simply supported. In the Izod test we will be putting it as a cantilever. Okay guys, yes, Fine. Fine, guys. This is something known as the toughness test. Thanks, Sajal. So this is something known as the toughness testing, my dear. Okay. So, my dear, these are hardness and toughness testing. Now, my dear, I am going on to, yes, this we have already seen. This is how the Izod test is performed. For Izod test, this is a cantilever kind of case. So this is a kind of cantilever, yes, because you are fixing this workpiece here, it is acting like a cantilever, and when this will be pushing it here, it will be getting failed from here, because cross section area is minimum here. So it will be getting fractured from here, and this is how the Izod tests are performed, my dear. This is how the Izod tests are performed. So my dear, now I am telling you one more test will be there. One more test will be there. This is the shore celenoscope we have already seen. This was a diamond indenter which is coming from a height. You will be measuring the height of, yes, reboundness, and that will give you the hardness. Yes. Okay. This is the cone shape indenter of Vickers test. For Vickers test, this is how the indenter looks like. Now, my dear, I am coming for tension test. When you are going to perform a tension test, my dear, obviously you will be having a dog bone shape of specimen. A dog bone shape. And in this dog bone shape, my dear, this part and this part are tightly held by the jaws of the machine. And now some forces are being applied onto it. And my dear, we are going to see only this length. It is said to be gauge length. And my dear, this test is performed under the guidelines of ASTM, where ASTM refers to American Society of Testing and Materials. Under the guidelines of ASTM, American Society of Testing and Materials, and when this test is performed, my dear, obviously the other guideline is length is 2 inches, diameter is ½ inch. So the L to D ratio is going to be 4. These are the guidelines of ASTM. It is not compulsory to follow the guidelines of ASTM. It is not like if you will not be following the guidelines of ASTM, it is going to be a loss for you. No. Guys, as it is a standard test, so to make it standard, guidelines are given. Even if you are not following the guidelines, you will be getting the same result as you were getting before. So there is no point in that. But still, if somebody asks you under which guidelines this test is performed, it is the guidelines given by ASTM, American Society of Testing and Material. And based on this test, when you are going to plot a diagram, guys, this diagram is said to be the stress strain diagram, or you can also make load deformation diagram. As this is the general session for all the branches, we need not to go into much detail of this diagram. Otherwise, I teach this diagram for 3 to 3.5 hours. For core engineers, core mechanical and civil fields, it is not required for ECEE and all other branches. It is required in detail for mechanical civil, but for paper 1, a few glimpses are required that I am giving you. That whenever we are going to make the load deformation diagram, you will be getting a curve like this. And you know there are certain points what we are going to discuss, not in detail, only a few points. So as already I said, when I teach this diagram, I teach it for 3 to 3.5 hours. If you really want to have that much knowledge, if you are from mechanical or civil, you can search my lecture over stress strain diagram on the same YouTube channel. You will get 2 to 3 such lectures where I have taught the stress strain diagram, and I have taught in a great detail. In 1.5 hours, I just discussed this diagram. But my dear, for ESE paper 1, it is really not required. So for ESE paper 1, for all other branches, for ECEE peoples, you need not to go into that much detail of this topic. So my dear, that's why I am telling you some important points which are required for ESE paper 1. There is a point up to which material obeys Hooke's law. There is a point up to which material obeys Hooke's law. That point is said to be elastic limit. So Hooke's law says stress is directly proportional to strain up to elastic limit. So my dear, up to the point you are having stress strain relationship to be sigma is some k times epsilon to the power n, means the curve is linear. That point is said to be proportional limit. Okay, that point is said to be the proportional, not elastic, proportional limit. Up to which, my dear, material obeys Hooke's law, up to which you are having the load deformation diagram to be a straight line, it is said to be proportional limit. After that, a point comes known as elastic limit. Stress strain diagram and load deformation diagram comes like same only, because stress is load by area, strain is delta by L. So by area and by length will be acting like a scale factor only. So my dear, when you are going to have this is proportional limit. After that, elastic limit is the point up to which material is showing the elasticity. After elastic limit, material's behavior will not remain elastic and you will be coming into some zone where permanent deformations will be taking place. So my dear, this region of the diagram is said to be the elastic region. After that, material is having a upper yield point, which is a yield point of no significance. There is no significance of upper yield point. It is not a real yield point, it is imaginary, it is a dummy yield point. There is no use of this, no physical significance. This is the lower yield point, which is the real yield point of the material, because yield point is something after which the material stress increases. Material strain increases at constant value of strain. Material strain increases at constant value of stress. And that region of the diagram is said to be the yielding region. And my dear, then you will be having the increase in stress up to this point known as ultimate point. And my dear, this will give you the ultimate tensile stress. After that, my dear, material starts fracturing, some cracks are generated. So this region is known as strain hardening because material's resistance is increasing. And my dear, this region is said to be strain softening. Strain softening. Because my dear, material got some fracture, you can say there are some cracks are generated. So that's why it is said to be necking region. And in this region, my dear, stress is coming out to be directly proportional to strain to the power n, where n lies from 0 to 1 for mild steel. I already mentioned why low carbon steel is said to be mild steel. My dear, low carbon steel is said to be mild steel. Sometime I asked in the classes, the students gives the answer because it is having less amount of carbon, that's why it is said to be mild steel. My dear, less carbon is giving the name of low carbon steel. Then why it is said to be mild steel? Because my dear, whenever we go for improvements of properties of low carbon steel using some processes named as heat treatment, then my dear, the improvement shown is very, very less. Like when I am going to teach you, I want to increase your knowledge, but if you don't want to learn, I cannot do anything. In offline, okay, I could scold you, I could yes, say you, and I could try to impress you, but in online, it is totally on you whether you are coming to class or not. Like I feel you are not learning, if I am going to scold you, you may go from the class and I cannot do anything. Yes, so my dear, definitely, as I said, that it will be totally depending on you, not on me. So the same way, when you are going to improve the property of low carbon steel, it will not show a good response. So when it is not showing a good response, we say it to be less responsive, and the technical word used for less responsive is mild. That's why we are saying low carbon steel to be mild steel, because the response to the heat treatment is very, very, very poor. So if I am teaching you something, I am asking you something, your response is poor, I will be saying the batch is very mild. But I don't want you to be mild. I want you to be more interactive. Okay, and yes, many of you have already answered about that also. So that is something known as, my dear, mild steel. So guys, today we have discussed a lot of mechanical properties. One more property is coming into my mind, that is creep. There are endless, any number of properties. Creep. My dear, let us say you are having a ceiling fan. That ceiling fan is there onto a rod. That is always applying a load onto that, and that load is up to elastic limit only, because we do not allow the permanent deformation. So my dear, because of this load, the body will be having some elastic deformation. The meaning of elastic deformation is when you will be removing the load, this elastic deformation will be gained back by the material. So this is elastic deformation, my dear, for sure. But when you are applying the forces, it is elastic deformation. But my dear, as some loads are applied for longer times, then the elastic deformation are start getting converted into plastic. So after some time, my dear, some part of elastic may be getting converted into plastic. As the time passes, elastic will be getting converted into plastic, and that phenomena is said to be creep. This is more extensive when temperature effects are also there. At higher temperature, it is affecting more. Hope, my dear, you are getting it in a wonderful, nice manner. So today we have discussed the mechanical properties majorly. In tomorrow's class, we will be having a discussion over electrical properties. So guys, don't miss. And tomorrow, from tomorrow onward, we are coming back to our original timing, that is 11 a.m. So we are going to join tomorrow at 11 a.m. for this session. And our discussion will be about electrical properties, Hall effect and all we will be discussing in detail. And my dear, we will be having some previous years ESE question from 2016, 17, 18, 19, 20. Okay, we will be having that. Hope you guys are ready for the examination, or I will say not examination, for the test, for the questions. So please revise whatever we have discussed till now, so that when I will be doing the question in front of you, you guys shall not feel helpless. So guys, before leaving the session, please like, share and subscribe, so that your friends can also be benefited from these kind of sessions. And we are going to meet tomorrow once again at 11 a.m. for this session. And you can join me at 10:30 p.m. daily on Gradeup app if you really want to have a wonderful practice for other than ESE previous year's question. Guys, in that series, I will be quickly revising the session. Tomorrow I will be starting with project management there. Today there is a generic session where I will be telling you the subjects which are more weightage wise you should prefer in paper 1. Okay, and branch wise which subject you shall go with. And my dear, then I will be starting from tomorrow with the project management, and I will be revising all the subject, all the topics first. Then we will be solving some problems over that. Hope you guys are going to get a wonderful feel of that, and waiting for you guys. And from today it is going to be starts. Fine. Thanks Sajal. Goodbye guys for this session. Thanks for joining. We will meet at 10:30 p.m. today on Gradeup app, and tomorrow at 11 a.m. on this channel, the same platform, the wonderful Gradeup. Goodbye guys for this session.